So let me have the exam next Monday. So this will give us enough time to finish a few important topics this week. Okay. So we won't postpone it after that. So for sure we'll have it next week. Okay. All right. So last time we were looking at interfaces. Okay, and we discussed that we can create custom interfaces, meaning we define the interface, or there are already predefined interfaces in the library, so we refer to them as standard interfaces, right? So we were looking at some of these popular interfaces, such as IClonable, IComparable, and IComparer, and so on. iQuality comparer, and there's many. Okay. So as a minimum, we should know 3-4 of these very nicely. Okay. So last time we looked at iClonable, and you guys saw that anytime you create a class, let's say XYZ, if you wanted to be able to make in-memory copy of this particular class object, then you will implement iClonable, right? C# uses the same syntax as inheritance for implementing an interface, because interfaces act as base references for all practical purposes, right? Okay, so as soon as we do this, and if you right-click on it through quick actions, implement interface, it will give you a public object clone method, right? And now you can write your code in it. Okay? So we discussed that if all the fields in your class, whatever fields you have declared, if they are basic data types, okay, meaning it could be int, double, string, right? There's no object of a class or no array over here, okay? So in that case, what kind of code do you write in the clone? You simply write one line of code, and what's that? Return this dot member-wise clone. So we discussed that member-wise clone only does shallow copying, right? So it basically assigns one field to another. So now if we have, instead of basic data types, we have also some, let's say, class object. Or we have, let's say, an array as part of the fields of our class, right? So then member-wise clone will not work. So for these types, what do we have to do? Further, we have to call the clone on it, right? So for example, our code in that case will become XYZ, let's say x1 equal to XYZ. So we'll make a shallow copy, store it at x1, for example, right? Then what do we have to do? Then you have to go one by one. Suppose this field is called address or ADDR, right? So you will say x1.addr equal to this dot addr dot clone. So what does that mean? If this was a class called address, somebody has to implement iClonable on it. So if you created it, you will implement iClonable on it, right? Further, so you'll define the same clone over here. If it's an array or a list, then or any other .NET library class, .NET library already implements iClonable for most of its classes. So for example, let's call it, let's say ARR is the name of the field over here. And suppose it's an array of doubles. If that's the case, then what will you do? You will say x1.arr equal to this dot ARR dot clone, right? But then clone always returns an object. So what should we do over here? We will typecast it to our double left square bracket, right square bracket, left paren, right paren, and then this thing will go over here, right? So, so this way we can implement the cloning property, okay? Anyway, coming to IComparable, the purpose of the IComparable is to be able to compare two objects on a particular field. So for example, if you created a student class, okay, and you wanted to do something like this, let's say S1 is an object of the student class, okay, and you wanted to be able to compare to S2, right? So whether S1 is greater than S2, or S1 is less than S2, or S1 is equal to S2, right? So the way the compare to method is provided to us is it's part of the IComparable interface. Very similar to like the clone is part of IClonable interface, right? So very similarly, compare to is part of the IComparable interface. Okay. What does clone return? Object, right? What does compare to return? Compare to returns. Remember, there are three possibilities. Two things could be equal, right? S1 could be equal to S2, or it could be less, or it could be greater. So the way this compare to is designed is it always returns an integer. If this is 0, so what does that mean? S1 is equal to S2. If it is -1, what does that mean? S1 is less than, and +1 means S1 is greater than S2. So anytime we call compare to, you will get one of the three possible numbers, -1, 0, or 1, right? Okay. So now we can use it in comparing two simple things. We can use it in sorting as an example, right? To give you a small example, actually let me do this so that you guys can also see some of the other neat things. Let me program it on the computer. So at least it worked right away today. So anyway, so let me create a new project and store it in our fall 2015 folder, right? And let me call it, let me just call it sort application, sort app, okay? So we'll do some kind of a sorting. So I'm creating a Windows Forms application, Visual C# sort app. If I click OK. Alright, once it creates the skeleton. Okay, so now let me go first bring our student class from our previous example. So if I right click, add existing item, and go to our What was the last one we were doing?
Interfaces.
Interfaces. Okay, and let me change this to, okay, or I can leave it over here. Let me just change the name of the namespace to sort app. Okay, we already have IComparable. Okay, now one class can implement more than one interface. It's okay to implement more than one interface, right? So let me address what happened. Oh, I also need to bring address. So add existing item address. And if I go to the address class, let me also make it the same namespace. So, sort app. Okay, so back to student, right? Let me also override the toString so that we can easily see what data we are, if we are sorting. So I will do public override, and then double click on the toString over here, and then return, let's say, first name plus last name plus id.toString plus test1 toString plus test2 dot Okay, so anyway, this is our simple toString method, right? So that we can at least see what data we are looking at. So now, to implement sorting, we need to be able to compare two students. So the question is, if we compare two students, or if we sort a list of students, what do we sort on? Do we sort on first name, ID, test1, test2, and as you will see, that's the job of the IComparable. So if I go IComparable, so as I mentioned, one class can implement as many interfaces as we feel like it, okay?